So we're in section 3.4, and we're talking about multi-step inequalities. Luke, you should take notes in your notebook, not on the desk. All right, so like I said yesterday, inequalities, solving inequalities, exactly like solving equations, except for our special rule when we multiply or divide both sides by a negative. So I want to remind us what our steps are when we solve equations. So this is our steps. Usually we do these things. These are not hard written in stone that we have to do them exactly like this, but this is how we usually do them. Usually, clear fractions. And then we distribute. Usually after we distribute, we want to combine like terms. And a reminder on like terms, combining like terms means we're combining things on the same side. So on the same side of the equal sign or on the same side of the inequality. So we're not going across when we are combining like terms. Then we want to get variable on one side. One side of the equation or one side of the inequality. We want to get all the x's together on one side. Then we're going to undo addition and subtraction. And then finally, we want to undo multiplication and division. And with inequalities, we need to remember our special rule for inequalities. Special rule is if we multiply or divide both sides of the inequality by a negative, then we have to turn the arrow around. So that's our special rule. So really all I want to do today is go through some examples. So I'll do some examples. I'll have you do a couple of things. Okay, so let me start with this one. So we have 2 times x minus 1 less than or equal to 2 minus 3x. So what's our first step here? Distribute. We have these parentheses, so we want to distribute. So when I distribute, I get 2x minus 2 less than or equal to 2 minus 3x. I don't need to clear any fractions. We've already distributed. I don't have any like terms that I need to combine on one side of the equation or the inequality. And I'm going to write over here just in parallel, just to remind us, if this was an equation, we would do the same step first. All right, so what's our next step here? We have these x's on both sides. Let's get all the x's together. So how do we want to get the x's together? Subtract. Which side do we want to get them on? Let's decide that first. Get them on the right? Okay? So to get them on the right, I'm going to subtract 2x. And I'm going to do the same thing if it's an inequality or an equation. Well, these go away on this side, and I get negative 2 less than or equal to negative 3x minus 2x minus 5x. Same thing here. Those go away. Negative 2 equals 2 minus 5x. All right, what's our next step? So we want to get the x by itself. So we got to get this away from the x. So what are we going to do here? Subtract. We're going to subtract 2. Do that for both of these. Same thing. Those go away. Those go away. And I get negative 2. Whoops. Got to subtract 2 from both sides. Got a little ahead of myself. Negative 2 minus 2 is negative 4, less than or equal to negative 5x. Negative 2 minus 2 is a negative 4, equals negative 5x. My last step here, what am I going to do? Yeah? Divide by negative 5. So here I'm going to divide by negative 5. My color changed there. And here I'm going to divide by negative 5. Well, on the equation, a negative, those go away. I get x equals. Negative divided by a negative is positive. I get x equals 4/5. For my inequality, I'm dividing both sides by negative 5. This is where I have to remember to switch. Well, negative divided by a negative is positive. And then I turn my arrow around because I've divided both sides by a negative. And I could rewrite this if I wanted with a variable on the left. I can just turn this around, x less than or equal to 4/5. The arrow's pointing towards the x here. It stays pointing towards the x here. I'm just thinking of picking this first one up and flipping it over. And they mean the same thing. But we follow the same exact steps as we did for our equation. We just had to be careful with our special rule there when we divided by negative 5. Now I have a question for everyone. Up here, when we got our x's together, could we have added 3x to both sides instead of subtracting 2x from both sides? Yeah, it doesn't matter which order we do it in. We'll get the same answer either way. If we would have done the inequality this way, at the end we wouldn't have ended up dividing by a negative, and we wouldn't have had to switch this around. But we'd still get the same answer. All right, questions? Okay. I want you all to try this one. 6 plus 3t is greater than 15. So I want everybody to work on solving that thing. All right, so what's our first step here? Someone help me out here. Yes? Subtract 6. So these go away. The 3t comes down. And I get 3t is greater than 15 minus 6 is 11. No. 15 minus 6 is 9. I was seeing if you were paying attention. I heard someone say, all right, next step. Yes? Divide both sides by 3. These cancel, and I get t. Do I have to turn my sign around? No, I did not divide by a negative. 9 divided by 3 is 3. So my answer is t is greater than 3. All right, let's look at another one. 4p plus 3 is greater than 9p plus 6 minus 5p. So what is going to be my first step on this inequality? I need to combine like terms because I have a 9p and a negative 5p on this right-hand side. So 4p plus 3 is greater than 9p minus 5p is 4p, and we still have the plus 6. So what's our next step? Yeah? So we want to get the p's together. So is that what we're saying? Yeah? So I subtract 4p from both sides. Well, 4p minus 4p, that's 0. And I get 6. 4p minus 4p is 0. And I get 3 is greater than 6. Wait a minute. Is 3 greater than 6? No. This is never true. If we get something that is never true, what does that tell us? No solution. Very nice. No solution. So this is what I want you to add under your additional notes. If you get something like 3 is greater than 6, something that is never true, that means you have no solution. So you could write something, you could write this exact, what I have in this square. You get something like 3 is greater than 6, something that is never true, that means you have no solution. So just like with equations, we have to be careful of a no solution. Or, we're going to add one more thing. If you get something like 2 is less than 10, how often is 2 less than 10? Always. This is always true. If you get something that is always true, that means you have an infinite number of solutions. So if you get something that is always true, that means you have an infinite number of solutions. On the last test, we had one problem on the test that turned out to have an infinite number of solutions, and it asked you to say why you know. And my favorite answer was someone said, I know because Mr. Beamer told me that same number equals same number means infinite number of solutions. So that's a reason why you would know. So if you get something that's always true, that means you have an infinite number of solutions. So that can go under your little flap also. Okay, I want to look at one last problem. Actually, I want you all to try this one. N plus 2 plus 3n, n plus 2 plus 3n, is less than 7n minus 13. So give this one a try. And depending on how you do this one, you might need to be careful at the very end. All right, so our first step, what's the first step that you all did? Combine like terms. So here on the left, we have an n and a plus 3n. So we add those together and we get 4n plus 2 is less than 7n minus 13. Next step. What did we do? Subtract 4n, okay. We can do it that way. These go away. I get 2 is less than 7n minus 4n is 3n minus 13. Next step. Yeah? Add 13. Okay. Those cancel. That comes down. 3n less than 13 plus 2 is 15. And finally, divide by 3. 15 divided by 3 is 5, is less than n. Now, if you subtracted 7n from both sides, you would have a negative. Let me go through that. I'm just going to write that one up here in blue. If we did 4n plus 2 is less than 7n minus 13, and we decided to subtract 7n from both sides, I can do that. Those go away. This comes down. We have a less than. 4n minus 7n is negative 3n plus 2. I would subtract 2 from both sides next. Those go away, and I get negative 3n is less than negative 15. And then I divide by negative 3. Those go away, but I've divided by a negative. Here I would have to switch. Change my arrow, and a negative divided by a negative is a positive, and I get n is greater than 5. Are these two the same? Yeah. The arrows pointing towards the 5 on both, they are the same thing. So you get the same answer. Either way, I would accept either of these answers on a test. Yes?
I feel like the right one is too hard.
If you can avoid using negatives, usually it's a little easier. I try to avoid negatives, but I also like to have my variable on the left-hand side. So sometimes those fight against each other. But yeah, negatives make it a little more tricky to do. This is pretty straightforward. Okay. Homework for today is from the book. So let me get the book page. Oh, it's actually up on the board as well, page 190. 10 through 32 even. And then 44, 51, and 54. And this is section 3.4 in the book.